Welcome to the Courtyard Marriott. During today's webinar, we're going to be showing you software-defined LAN in a working environment. If you recall, in our previous video, we did software-defined networking, and we did a deep dive on software-defined networking. Today, we're going to show you this in a live environment, so you'll get to see all of the various applications that we're running via a deep fiber optic network. The topology that you're going to see at the Courtyard Marriott is we're going to have the WAN circuit, which is going to enter the building. This is the internet circuit. This is going to connect into our software-defined virtual application host. This is an x86 edge computing device. This is where we're going to have our virtual router. This is also where we're going to be able to virtualize applications like Wi-Fi or other kind of applications. This will connect in to our software-defined data plane. The software-defined data plane is a white box switch. This is going to be running the orchestration platform. From the software-defined data plane, FIBRE leaves. This is going to ultimately connect to the software-defined access node, or ONT. This is where we're going to have our O to E conversion and connect to all the applications that we're serving, such as Wi-Fi, point of sale, BMS, etc. Along the way in the IDF closet, we're going to be injecting power. So this entire facility has centralized power. So the power is going to be coming from the MDF or the IDF locations. We're going to inject power into composite cable. Composite cable has both fiber for connectivity as well as power to power that end device, which is the ONT. To recap from our last video, we're going to be talking about software-defined networking. And again, the basics of software-defined networking is we're going to separate the intelligence of the network, which we call the control plane. This is where all the management, and this is where we're going to assign all the flows throughout the network with the data plane. The data plane is going to be where we're going to be just passing packets from point A to point B. This is a really an advantage of a fiber network. And so what you're going to see, or the growing trend is outdoors, we start off with fiber to the building. We have lots of fiber to the node. We have fiber to the home. What's driving that is really the need for bandwidth. Same thing is happening indoors. So SD data centers is a big trend, and if you look at any of the big data centers from Google, Apple, et cetera, you're going to see they're very fiber-rich environments. You're seeing the same thing with SD-WAN. So the circuits coming into these small businesses and hotels, also we're starting to utilize fiber, which is just now the common media because we need that high bandwidth. What we're going to be showing you today is SD-LAN, where we're bringing both fiber, which is providing the bandwidth, as well as power to power these end devices at the end location. Right, so this is going to allow us to bring in lots of applications. It's going to allow us to grow with the needs of the hotel. And so I think it's something exciting that you're going to see, and I'm looking forward to showing you the hotel. At this Courtyard by Marriott, this is a 144-room hotel, and so what we're going to be showing you is fiber scales up very high, so we do a lot of higher-end facilities, but we also scale down very well to these mid-tier properties like this Marriott Courtyard. When you walk into the facility, we have the IP connectivity for everything that you will see. So when you walk into the lobby, we have the the property management system, Wi-Fi, security. As you wrap around the corner, you'll see the conference rooms. In the conference rooms, we have both hardwire drops as well as Wi-Fi connectivity. There is a bistro and restaurant in the facility where we have both IPTV connectivity as well as Wi-Fi and additional point of sale. There's the fitness center. In the fitness center, we have all the connectivity to the exercise equipment so you can watch content via IPTV as you're exercising. Now let's draw this out from a topology standpoint. So for our property management, we're going to have distributed software-defined access nodes, or ONTs, which are serving the point of sale systems and the property management system. It will serve Wi-Fi and security cameras. These are in zone locations on the first floor. We also have the conference room locations. We have more software-defined access nodes, or ONTs, which are providing the connectivity for our physical drops in the conference rooms, as well as Wi-Fi. In the bistro, we're serving IPTV, Wi-Fi, and point of sale. Again, these are being served by ONTs that are very close by. And then finally, in the fitness center, to kind of round out our public areas, we have ONTs in the fitness center, which is the connectivity to the IPTVs and the Wi-Fi, which is physically located in the workout facility. And then we also, when you get into the rooms, we're providing your typical triple play that you would see in a hotel. So that's going to include IPTV for video, it's going to include phones, which you'll see, and also high-speed internet access via Wi-Fi. In this particular property, there was no need for cellular enhancement, but that's also something that's commonly that we see in larger hotels. We do that in two ways. So again, the Corning platform is a both fiber and power deep network. We have a distributed antenna system that we can hang off this same fiber, or depending on the needs of the venue, oftentimes we'll distribute small cells, which we can also enable via the SD-LAN platform. Other common applications that we'll see: audio-visual, HVAC control, wayfinding, BMS, any kind of connectivity need that we have in a facility we can handle via the one platform, so one-stop shop. Jumping back to our virtual whiteboard, in the guest room we have optical network terminals or software-defined access nodes. This is, we've composite cable feeding these devices. In the rooms, that's our triple play, which is IPTV, voice, and Wi-Fi access points for high-speed internet access. In some properties, we also have the need for cellular. If that was a need, the way that would look is we would have our remote antenna units. This would provide our cellular signal, a neutral host cellular signals from the various carriers. Or as an alternative, we could also deploy radio nodes or small cells, which would be connecting into our ONTs. Other applications that we often see in facilities is audio-visual, HVAC control, wayfinding, and BMS, or building management systems. Again, these are all IP devices that would connect into our software-defined access node, or ONT, and ultimately feed into our platform. Now we're going to look at the technology in the guest room. So in the guest room, we're providing triple play service. So that's video via IPTV, it's phone, and it's also high-speed internet access via Wi-Fi. So what we're going to talk about in the room is I'm going to show you some of the functionality of the IPTV system, and I'm also going to we'll do some speed tests to show you how the Wi-Fi works. So now that we're running the speed test, so I'm going to run a speed test. This is going to ping a local server in Charlotte, North Carolina. So this is a all fiber network. So there is very little latency, so you'll see this will go through quite fast. When it comes back, it'll start testing the speed through the network. So this is the path is the WAN connection that we talked about earlier. This is going to enter the software-defined data plane, fiber all the way to our software-defined access node, which is then wirelessly connecting to our my mobile device. And let's see what kind of readings we get. Wi-Fi at the speed of light. Now I'm going to demonstrate some of the IPTV functionality that we enable through the One SDN platform. So we have the guide functionality that you would be used to seeing, right, at your home or at a hotel. But we also have some advanced features. So what I want to demonstrate is the Chromecast functionality. So I click on Chromecast. What this is going to allow me to do is this is going to allow me to cast content directly from my phone or to any other mobile device, my tablet, directly to the TV. And now I can control that TV directly from my phone. So I can pause, I can play, I can change content. A really nice feature for hospitality because nowadays people are bringing the content with them via Netflix, Hulu, HBO to go, etc. Some other features that we have on the IPTV. We have the bistro. So this would be if you want to order room service or if you want to see what's going to be for dinner tonight. You have weather, both from your current location as well as where you came from, your home city, news, etc. So really nice functionality that we're enabling via the platform. So this is the phone that we have at the Courtyard. In this case, we're utilizing the SIP port on the ONT. In some other properties, we utilize VoIP or voice over IP. And so that would use a standard Ethernet port off of the ONT. This is a smart thermostat. The smart thermostat is enabled via Zigbee, which is going back to a controller which we are bringing into the SD-LAN platform via IP. This is a wireless door lock. The wireless door lock also can come back to a Zigbee gateway, ultimately flowing back through our SDN platform. And Wi-Fi. So Wi-Fi has become a mandatory function for hospitality. Many people complain about Wi-Fi before they would complain about losing hot water. So for these hotelers, having a quick and fast Wi-Fi, reliable Wi-Fi system is really critical. And then for some rooms, we also have a requirement for a physical connection for some government employees that need a physical LAN drop for their PCs when they're working from a hotel room. So we've talked about the technologies that we're enabling in the room. Now let's look behind the scenes to see how all of this is occurring. So when we talked about applications, we talked about our high-speed internet access, which was enabled via Wi-Fi. So this is our Wi-Fi access point. We discussed the IPTV functionality. This is the set-top box, which is enabling that. Next, this is the software-defined endpoint from Corning. So this is providing PoE plus output out, which is feeding the connectivity for the set-top box, the Wi-Fi, and in this case, it's also feeding a set-top box, which is in the adjoining room. This is our surface mount box for the fiber termination. So we're bringing in composite cable from the IDF, which we'll visit next. That composite cable is getting split out, so I've got both fiber and power, which is the fiber connectivity as well as the power for our software-defined endpoint. And that's how we're enabling all these services in the room. I'll also point out that we have SIP ports on this ONT, which is enabling the phones. Alternatively, we also have in-wall models of our software-defined access nodes. What you're seeing here is we have a conduit path into the room. The fiber will terminate in the back of the ONT in a gang box. From here, we have the fiber connection into the ONT. This would typically serve two rooms. So the first room would take an Ethernet port, which would connect to our Wi-Fi access point. It would take another Ethernet port to connect to our IPTV. And then we also have an Ethernet port on the back of the ONT, which would serve the adjacent room. So now I can serve another IPTV in the adjoining room. Jumping back to our virtual whiteboard, what you're seeing is we have our patch panel, our fiber patch panel. This is getting its IP connection from our software-defined data plane. So here I have gigabit SFPs, which are going to patch into my patch panel. This is also where I'm going to inject power via the power supply unit, or PSU. So I have power coming from the PSU to the patch panel. And now out the back of the patch panel, now I have composite cable, again getting its fiber connectivity from the software-defined data plane, getting its power from the PSU. Then composite cable will leave that closet and will serve the guest rooms. In the guest rooms, the ONT, or software-defined access node, is serving our triple play. High-speed internet via Wi-Fi, voice, and also video via IPTV. Alternatively, we also support PON. In a PON architecture, what it would look like is you're still going to have that same patch panel. In this case, we're going to be substituting an optical splitter for the software-defined data plane. The optical splitter is going to get its feed from the OLT that'll be in the MDF closet that we'll talk to here in a little bit. And then there's 32 outputs. Those 32 outputs are going to jumper into my patch panel. I'm also going to be injecting power, just like for active Ethernet, from the power supply unit. So I'm going to have a 100-watt circuit that's going to jumper into my patch panel. And then out the back of this patch panel, I'm going to still have composite cable, which will serve that same software-defined access node, giving me my triple play services: high-speed internet, voice, and video. This was a brownfield installation, and what's common in brownfield is we didn't have traditional IT closets. So now we're going to walk into this closet. This is a linen closet, which we decided to take a little nook of this linen closet as our IDF to serve floors 2, 3, and 4. So we're serving 126 hotel rooms from this single closet. So from the rooms, we have composite cable leaving the rooms and entering this closet. The composite cables are coming in, they're terminating on the back of this housing. And now this housing is my patch point for both the fiber as well as the power, because remember, we're bringing composite cable into each of the rooms. The power is patching into the PSU. So this is where I'm getting my 100-watt circuits, which are feeding the ONTs. The fiber is coming from my software-defined data plane. As a reminder, this is the same software-defined data plane that we have in the MDF, which was serving our applications as well as serving some ONTs on the first floor. In this case, this is taking an uplink from that software-defined data plane on the first floor, and from here I'm aggregating out the signals throughout all the ONTs. So each of the SFPs that leave this software-defined data plane is a gigabit, and each of these are serving ONTs in the room. What that composite cable looks like, so this is an example of the composite cable that's going to the rooms. So you'll see I've got a composite cable, I have a copper pair, which is my power, right? So this is where I'm patching into my patch panel from the IDF, and this is also where I'm patching into the ONT in the room. And I also have my fiber connectivity, all under the same sheath. Another thing to point out in this location is, at this hotel we're using Active Ethernet. So the Corning One SDN platform supports both Active Ethernet. Active Ethernet is a point-to-point fiber connection, meaning I've got fiber leaving this switch feeding ONTs directly. Passive optical networking, or PON, is another technology that we support on the Corning One platform. In that case, it's a point-to-multipoint. So if this hotel was a PON installation, we'd still have fiber coming from the MDF to feed this facility, but then instead of having a fiber feed my switch, this fiber is going to feed a optical splitter, or a passive splitter. So I'm going to have one fiber into the splitter and 32 fibers out. So this is an Active Ethernet switch with 48 ports with gigabit SFPs. That would be option one with Active Ethernet. The other option that we support is PON, where I have single fiber in and then I have 32 fibers out to feed 32 fibers via a passive optical network. We decided to skip the closets on the second and third floor. On many of our greenfield installations, we'll actually eliminate all closets. We can do that because this is a fiber-rich environment, so we are not distance limited with the fiber, or in the case of the PSU, we're also not significantly distance limited for power as well in a hotel of this size. So for this installation, we utilize this closets. Some installations we serve everything directly from the NDF, and other installations we'll use small wall mount racks, just depending on the nature of the hotel. Jumping back to our virtual whiteboard for the last time, first we're going to talk about our applications. So we have IPTV via our DirecTV COM2000. We have Wi-Fi via our Ruckus controller. We have our access gateway via our Nomadix. And then we have our virtual application host, which is our connection to the WAN. All of these applications are going to connect into the software-defined data plane. From the software-defined data plane, we're going to serve some of the public area directly. So you'll see we've got a fiber patch panel. This is going to take in a fiber connection via an SFP connection out of the software-defined data plane. It's also going to inject power via the power supply unit. So now out of the back of this first patch panel, we have composite cable, which will leave and serve software-defined access nodes, or ONTs, in the public areas of the hotel. So this is serving things like security, point of sale, the fitness center, Wi-Fi, the conference room, etc. This is also our nerve center. So this is also going to be our connection to the other closet in the facility. In this case, we're going to talk about the fourth floor closet. So I have a CCH01U patch panel. So this is going to take a fiber out of the software-defined data plane, which will ultimately connect to the fourth floor closet where we have additional software-defined data planes. So here we're just going to have a quick patch or an uplink connection to our software-defined data plane on the fourth floor. Again, this is ultimately connecting into the software-defined data plane in the MDF. Then out of this software-defined data plane, we have gigabit SFPs, which are going to be serving ONTs in the guest room. So this is going to be a simple patch cable to our patch cable, our outgoing fiber, and I'm also going to be injecting power from the PSU. So I'll have a copper jumper just for power, jumping to the same patch panel. Then out the back, like we discussed previously, I have composite cable, which will go to the guest rooms, hitting a software-defined access node for my connectivity to Wi-Fi, voice, as well as video services. This is the MDF, or the head-in at the courtyard. So what I'm going to be walking you through here over the next couple of minutes is all the applications that we're feeding from this room. So this is the nerve center for this particular hotel. The first application we're going to talk about is the DirecTV COM2000. This is my IPTV head-in. So what I'm doing here is I've got 8 cards. Each card is serving 8 channels of content that's going to go to the TVs that are in the public areas as well as the guest rooms in this facility. This is connected to the roof where we've got the DirecTV dishes, which is bringing in that content off air. From here, this is an IP connection. So I'm going to leave via IP. I got my Cat6 cable, which is going to patch over to the Corning SDN-LAN software-defined data plane. So this is the SDN-LAN data plane. And so from here you'll see I've got patch cables, which is patching over to the COM2000 IPTV head that we talked about. And I also have some various other applications I'd like to step you through. So I have, this is my Ruckus Zone Director Wi-Fi controller. So this is going to connect into my software-defined data plane as well. I have an access gateway. So this is the splash page for Marriott where you would sign in to get onto the Wi-Fi. That's also going to connect into the software-defined data plane. This is my WAN connection into the facility, and the associated firewall also going to be entering into the software-defined data plane. This is my virtual application host. So this is where we're going to also virtualize some of those other applications into the platform, also connect into the software-defined data plane. So this data plane is serving 2 functions. So you see on the right-hand side, this is where I have all of my applications plugging in, and this is typically copper. So these are the Cat6 connections. So it's connecting into the various applications that I'm serving in this hotel. The left-hand side is my output. So this is the fiber leaving the software-defined data plane, which is going to connect into endpoints throughout this facility. And the way that's going to happen is this is going to patch from the data plane into the patch panel, which is serving this floor. So on this floor, the MDF happens to be on the first floor, so this is serving the business center, the bistro, and also a couple of hotel rooms that are on the first floor. The way we're doing that is I've got fiber jumpers. So these fiber jumpers are patching into software-defined data plane. But then you'll see I also have these black copper cables. This is where I'm injecting power, because on all of these locations I'm injecting both fiber as well as power to power those end devices. That power is coming from the power supply unit, Corning's power supply unit, or the PSU. So these are 100-watt circuits which are patching from the PSU up to the patch panel, leaving out the back via composite cable. I also have 2 patch panels at the very top. These are my connections to the other IDF closets in the facility. So I have a closet on the 4th floor, which is serving floors 2, 3, and 4. Then I also have a small closet in the back of house, which is serving some back of house office, like the general manager's office, printers, the property management system, etc. But again, this is the nerve center. From this point, I've got fiber out, and everything is being fed via a deep fiber network.